Welcome to Module HU003 of Oricon's Upskill Modular Training Program devoted to Revit and BIM. This module is titled Advanced Scheduling Techniques for Hydraulic Design Checks and is brought to you on behalf of Oricon by A2K Technologies. We will be using the purchased materials supplied by Oricon and A2K Technologies. Classroom notes and handouts are available for note-taking through the exemplar portal. Main objectives. This module will introduce specific scheduling functionalities as good practices for hydraulic engineers and designers to check and validate Revit models. As an example, we will use custom project parameters and embedded spaces schedules for validating automatically calculated fixture units. Throughout the training today, we will be covering the following topics: an introduction, creating spaces, custom project parameters, spaces schedules, embedded schedules, formatting schedules, and verification. Introduction. To follow this lecture, open the file Master MEP Hydraulic. Make sure that the ArcLink model is located in the same folder as the main file. All views referred to in this module can be found under B Working in the project browser under Plumbing. Open Floor Plan 01 Entry-Level Drainage Layout. Open the Visibility Graphics dialog box using the shortcut VV and ensure that all pipe and plumbing related categories are turned on. Zoom in to the bottom portion of the plan between grid lines 3, 4 and IJ. Notice that there's an example sanitary system pre-modeled made up of a small pump up here and 3 water closet fixture outlets down here. Open the type properties of one of the WC fixtures. Note that grouped under mechanical there are 3 preset parameters: water fixture unit, cold water fixture unit, and one for hot water fixture units. Any plumbing fixture element in Revit contains those 3 fixture unit parameters. At the end of this exercise, those parameters will be used in schedules for verification purposes. They can also be used for various calculations, including sizing of pipes. Creating spaces. We are now going to place a space over the room where the WCs are located so that we can schedule it. In the Analyze tab, we choose the Space tool and place a new space inside the room where the water closets are sitting. Hit Escape, select this new space, make sure that you don't select the space tag. Make sure you select the space. Under Identity Data in the Space Properties, notice the room number and room name that comes from the architectural model. Adjust the name according to the architectural model, male, and the room number as well, 107. The room tag should update automatically. Custom project parameter. Create a new project parameter which we will use to compare the required fixture units against the actual designed fixture units in a schedule. Go to the Manage tab, select Project Parameters and hit Add to create a new project parameter. As a name, we define specified fixture units. As a discipline, we select piping. The type of parameter is going to be fixture units, and we will group the parameter under plumbing. Make sure that the parameter is an instance parameter, and we assign the parameter to the category spaces. Hit OK. Hit OK. Select the space again and check in the properties whether the additional parameter shows up under plumbing specified fixture units. Spaces schedule. Create a new space schedule. In the View tab, select Schedules, Schedule/Quantities. Choose Spaces as the category and name the new schedule Fixture Units Check Schedule and hit OK. Add the following parameters from the available fields to the scheduled fields by double-clicking on the left side. First one is number. Second one is name. Third one is area. Fourth one is level. And the last one is specified fixture units. This is the project parameter that we added earlier in this exercise. Hit OK. Space number 107, male, is the only space that exists in the model and therefore the only space showing up in our schedule. For the specified fixture units field, put in 45. This is our target value we will use for verification later on. Embedded schedule. Use the embedded schedule tool that is available in the space schedule to embed the plumbing fixtures into this space schedule. Select the embedded schedule button from the properties window and tick the embedded schedule box. This will activate an embedded schedule function. Select plumbing fixtures from the list below as the category to embed and click on Embedded Schedule Properties to open the dialog box for the embedded schedule. Choose the following parameters from our plumbing fixtures to embed. First one is family and type. Second one is system name. Third one is WFU, waste fixture units. Fourth one is cold water fixture unit, CWFU. And the last one is hot water fixture units, HWFU. Hit OK. Hit OK. And we get a list of all the plumbing fixtures that exist in this space embedded within this space schedule. Their fixture units are also displayed both for the waste and for the cold water supply, seeing as each toilet has a cold water supply. Format schedule. We can further format this schedule to allow easy visual comparisons between the specified fixture units and the actual fixture unit totals. Open the Embedded Schedule properties. Go to the Sorting and Grouping tab and untick the checkbox for Itemize every instance. Also, go to the Formatting tab, highlight the 3 fixture units parameters, and tick the Calculate Totals checkbox. Hit OK and hit OK again. And notice that the schedule counted the total number for all the fixture units. Verification. As the final step in this exercise, we are now going to add a calculated value to the embedded schedule. This calculated value will allow us to compare the specified units with the actual units from the model. Go back to the embedded schedule properties. In the fields tab, click on Calculated Value, set the name to Total Fixture Units, set the discipline to Piping, type to Fixture Units, and as a formula you can select the three dots to find existing parameters, select WFU plus cold water fixture units plus hot water fixture units. This newly created value appears at the bottom of the scheduled fields list. Go to the Formatting tab, select our new value Total Fixture Units and select Calculate Totals. Hit OK and hit OK again. The schedule displays two parameters that can be compared for checking purposes. A hydraulic engineer can use the specified fixture units to run through all the spaces in the model and place the desired maximum fixture units values. This can be adjusted at any time to suit. Then, once the model starts being populated, the total fixture units will update for every space, and so the engineer or designer can quickly check that the total is not exceeding the maximum specified value. To clarify this further, we slightly amend the schedule in a way that the two values to compare are in the same column. We also add a couple of basins into the space to see how the schedule updates with the totals of fixture units. Edit the Fields tab in the schedule and add another random parameter. For example, space type. Move it one step up so that it ends up between the level parameter and the specified fixture units parameter. Hit OK. Go back to the floor plan 01, entry level drainage layout. Hit WT for tile windows. Zoom into the area at the bottom where our space is located. Go to your Systems tab and select Plumbing Fixture and choose one of the sinks. Select the 455 by 455 millimeters public one and place the sink on a work plane. Place it along this wall here and another one. Hit Escape, Escape. Have a look into your schedule and see that the parameters update automatically. The total fixture units for the space will have increased with these new units being added. Also keep in mind that this schedule could assist in the sizing of pipes using the fixture unit totals as a reference. This concludes our exercise. And that concludes Module HU003, Advanced Scheduling Techniques for Hydraulic Design Checks.